Do you take notes in either pad? Or,
I can.
yeah, do you want to try that this time?
Sure, I'll just go to the agenda website.
That's what I just did, yeah.
Yeah. Do that, yep.
Okay.
I've done that. Yeah, I've done it before.
So for everybody in the room, if you're going up to the mic, please make sure that your badge is name visible on both sides, please, so I can take down your name correctly spelled. Thank you.
Okay, so it's the time we start, and it's ISIS. The agenda is up there on the screen. I'll go to the update slide. Note well and stuff. All right, so we got that. We have a minute taker, jabber scribe. What was the last one? Meet echo support. No, we don't have that. So here's the note well. I guess part in bold I'm supposed to read. By participating with the IETF, you agree to the following IETF process and policies. If you're aware that any contribution to something written, said or disclosed in IETF context is provided by or covered by patents or patent applications, you must disclose the fact or not participate in the discussion. You understand that meetings might be recorded or broadcast, audio, video, photographed, and publicly archived. And the other details are covered in this. Okay, so the agenda bashing, I have one item on this. Russ White was going to present the Open Fabric ISIS. He also just did that in routing working group. So I'm curious what the number of people that were just in routing working group that saw that presentation. Raise your hands. And who has not seen that presentation? Okay, Russ, you got, there's 2 to 4. And a lot seen it. So I think you're last. So everyone else.
We'll just all walk out.
Yeah, just everyone's gonna walk out. Yeah. So Russ, raise your hand if people want to talk to him about Open Fabric. There he is. I think that's the only agenda bashing that I had. Did anybody else have any?
Yeah. So I was just thinking about Ethernet as it's maybe coming out like every class on all of any just by using it. So I'm gonna
Just do it manually.
Start. I can paste it in.
Okay, so the document status portion. So we have 2 RFCs that went forward, auto configuration and multi-instance, the BIS adaptation there that allows for multi-instance, multi-topology in multi-instance ISIS. And also my little tool kicked out 5309, and I was like, I didn't think that that was a new RFC. And I had to ponder why that was there. It was there because we had errata published on it this last time. It was a relatively minor errata on the point-to-point draft that just had some clarifications on what to do with ARP.
And unnumbered.
And unnumbered links, yeah. And numbered or unnumbered was the clarification. We have the L2 bundles in the RFC EdQ. I don't know if you know where that's at. You don't have to. Yeah, so this looks like I don't actually know what's holding us up at this point. Yeah, okay. So I guess we expect it to move forward.
My understanding is it's within the finishing touches towards RFC, no major roadblocks.
Okay, so we're looking to that RFC soon. We have 2 working group last calls. The beer one is actually, that's actually in beer. It's kind of, you notice beer comes before ISIS there. So that's a working group last call in another working group, but it affects us. The bold and these, by the way, are the presented ones. These are our updated documents. We have an adoption call for the Ginsberg ISIS-TE app. We also have contention on that still, which we hope to cover in this meeting, and any else contention should be soon resolved. There's the contentious draft, or one of, and that was submitted by Chris recently. And we have some individual documents that have been updated recently, and we have presentations for the spine leaf and the flex E. And that's the other TE proposal that's put together. So there's another topic. Have you been drafted? Have you heard anything on this? Of course. Okay. So the ADs want to combine the IGPs. Well, I'm sorry, I'm not allowed to refer to them as the IGPs, the link state IGPs. And go ahead, go to the next. So I asked for clarification, why do we want to do this? What problems are we solving? And we came up with these couple problems. It gives exposure to more experts, like where there isn't overlap. We get some new blood into both groups. And more people looking at the problem spaces that they face. There's less duplicated overlap work. I think that's the one that kind of drives this, is everyone sees like the segment routing extensions drafts that are literally duplicated, almost copy and pasted into both protocols specs. We didn't, the last time this came up, we didn't have that as much. We had a lot of the trill work going on, and we had, so when I ran the sort of stats on it, we were only overlapping like 20%. I haven't done that yet for this time around. I will. I suspect the number of overlaps are higher. So it does, I guess it's useful to look at it again. The issues that I saw with this, that I put in here, and are the groups have different audiences. Typically, OSPF covers a much larger audience and number of people or number of uses. ISIS tends to be like in a kind of a data center and a tier 1 area. And so there's sometimes the solutions look a little different. Like what looks better for one is maybe not as good for the other. Tier 1 is I mean, how you adopt changes and how quick you can make changes, things like that are maybe a little different. And also it may influence the choices to be the same. So whereas in before it might have been easier to pick a different route for the protocols, or because we operate in these different spaces, I think that's going to be less doable if we're in a combined group. And I think the want is going to be come up with a single solution for both. I think that's going to be the general intention most of the time. It may be harder to get work done trying to convince the other side. I mean, some people are ISIS folks, some people are OSPF folks, and they think about things differently. And we may get into these arguments that we wouldn't have gotten into before. And there are, for some people, they don't go to both groups, right? They're not interested in both protocols. So this does create more work. We can do, I put time in for a talk, so let me just finish this last slide. And then, so by more work, you can see that that's already going to start, because the proposal that I negotiated with Alia was that we would run a joint session next time, and that we would combine the mailing lists. So they will still be ISIS and OSPF mailing lists, but OSPF mail will go to ISIS and ISIS mail will go to OSPF. So we can start and feel over the next 4 months and the next working group what this looks like, right, and what it feels like. Thoughts?
So, Lova Anderson, can you go back one slide? I want to actually challenge the less duplicated overlap work, because you are extending the protocol separately. So you actually do the same amount of work. Now you do it in 2 working groups. The joint working group will have to do it in 2 separate documents. And it's not a given that that is actually less work, because the confusion between the two drafts is potentially getting more confusion between the documents if you have them at the table at the same time. So, and especially the T extension, we have seen quite a nice work between the GMPLS, MPLS working groups and the separate protocol working groups. So I'm not. Everything else I think is fine, but the claiming less duplicated work, I don't think is a good idea.
Yeah, so I think you're suggesting that it's more subtle than that. There's still going to be some overlap, because we can publish one draft and have two sections, ISIS and OSPF, in it with any kind of duplicated work or descriptions above it. The benefit there, I do see. I'm not all for this idea, by the way, but the benefit there is that you do have one place of the high-level description of what you're trying to do, right? And then you literally keep the mechanics down to just the mechanics.
By default, putting TE solutions into the same document I think that's close to disaster. You have to have a separate document that you can refer to when you're doing design. You don't cross over to the other protocols and things there.
So Les Ginsberg, just kind of following up on Loa's point, I think it would be a big mistake to try to take a particular problem space and make one draft that extends both protocols. I think that would be very confusing. What would make sense to me, if we're going to do this, is sort of I guess it's the PIM, MBO, and D model, where they meet together, but there are still two working groups and two chairs. So, my 2 cents.
There is actually plenty of seating space here in the front row, please.
So, well, I mean, so Les, to that point, that's why I kind of requested the joint session. Is that what you're thinking, that would be enough to solve the issues that the ADs have recognized?
Yes, I mean, if part of the goal is let's get the same audience for both IGPs, because we are solving a lot of the same problems in both working groups, fine, have one meeting. So now you get everybody attending together.
David Lamparter. So I would like to point out there's a single instance I'm aware of a common draft between OSPF and ISIS, which is the point-to-point over Ethernet broadcast thingy. I think that's both a positive thing and telling us that it's possible, but also a boundary on that simple, like it needs to be that simple to be possible. But also I think there's a misunderstanding on this slide in terms of areas, because my personal experience with operators is that it doesn't matter what the use case is to decide what protocol they use. It matters what they, as a person, really started with and are comfortable with. And I know a lot of people who run ISIS and smaller networks. It's not a large chunk, but still, I don't think this is valid to make as an assumption that the protocols are this clearly delineated in usage space.
Well, so David, I hear what you're saying, but the small groups, I think, are enthusiasts, right? I mean, they're not people that are coming to IETF and doing routing protocol or doing custom. I'm not saying they're not important, but OSPF, I think, has a wider scope of users, different types of users.
So I think the argument that I'm trying to make here is if you happen to be, for example, hiring a company that designs your network for you, they may very well put ISIS on your 2-router network that only has 3 subnets or something. Okay. So, and I've seen that happen.
Good.
So I support this proposal. I think one area where the 2 working groups, I think, have not been doing a particularly good job is in documenting use cases for extensions. The use cases in both of the IGP or link state IGPs are generally pretty similar, and so that work could certainly be combined. And perhaps part of the reason it hasn't been done is because we'd have to do it in OSPF and ISIS, 2 more drafts in addition to the 2 encoding drafts. And if it were only 1 draft for use cases for ISIS and OSPF, and we really agree upon those before we jump into encodings, that might have a great benefit.
Michael Abramson. So wouldn't we need to identify gaps in features between the currently and fix that disparity before this can be done, or that would be like one of the first things that we would start working on if this happened?
No, I don't think that it's that would be in the charter work, and I don't think that we would charter ourselves with the goal of making the protocols feature reaching parity on all features and doing gap analysis and stuff. I think it would just literally be running them together.
Okay, so in case one thing that we want to do requires more work on one protocol than the other, then that would over time just automatically fix itself for the things that are needed. Okay.
I think AC Lindum, I think when we talked about this 3 years ago, we weren't as far along. Now we pretty much, it's different encodings, and we shouldn't get hung up on the size of the TLV types and the length and things like that too much with the encodings and try and say, oh, those have to be common, because then you run into problems. But, or, there's a different level of granularity in the information. But now that we have TLV mechanisms for the base OSPF LSAs, and we have implementations, and we pretty much can do it all the same things. So it should get to be more of that. Now, granted, we're going to have enhancements like all the data center flooding optimizations that maybe I mean, I think it might make sense to do them in one protocol first, and then if they're successful and adopted, then do it in the next protocol. But I don't think in terms of things you can do. I think you'll do it in a different way, but you can do anything in either protocol. Okay.
Jean-Maurice.
Okay.
I definitely support this idea of merging the working groups. Of course, there is some not fully aligned audience between them, but it's not a first group which would have people interested in some topics and not others. I've been attending TEAs for some time for some of the topics, not all. There are people involved in LDP and MPLS, not in RSVP. There are various working groups already covering multiple protocols with misaligned audience, and it's not an issue at all. On the other hand, it could also be beneficial because sometimes people get lazy, they push an extension in one protocol and forget to promote the other one, while there are some people who could be interested in having the same level of feature in both. So combining working group will help address those missed feature on some corner cases. So I support that. Thanks.
Can we get just some sense of the room of the people who think that merging groups might be a good idea? Any people who seem to believe that merging groups is a bad idea?
By the way, that was about a 50-50 split.
Okay.
Yeah, so this will need more discussion. We're going to do the joint sessions. I personally like the idea of stopping there. I mean, that's just my personal opinion. I think we can solve a lot of the problems by running a joint session. I don't think that we have to necessarily have an IGP group. And also, it'll change the work makeup, and I may end up having to review a lot of OSPF documents. I don't like that. Okay.
First one is Wes.
Did you do? Oh, you need to plug something in.
I'll do your slideshow to this.
Does it work?
Wait, 1 second.
That was too obvious.
That's your firewire. That wasn't you.
Yep.
Okay, I'm Les Ginsberg. This is an update on the TE attributes draft for application. Just a reminder of the motivations. We wrote, oh, this doesn't work.
The mic doesn't?
No. I mean, I thought I was gonna.
Oh, that's a. That was giant, beautiful screen.
Yeah, that's all right. I just thought I could be like a real TV host or something, but. So we did this principally because there currently is no way to deploy multiple applications and have an indication of there's only one way to advertise link attributes per link, and there's no way to indicate which set of advertisements should be used by a particular application and whether the advertisements on a particular link are not to be used by a particular application. So that's the problem we set out to solve. Acknowledgement to Peter in the OSPF draft, because that was the initial definition of the problem and a solution. And this is equivalent to Peter's draft in OSPF in terms of the solution. So what are the requirements? We want to indicate on a per application basis which links have advertisements that are to be used by a particular application. Note that this is not enabling an application. It's not an indication of whether the application is enabled on the link. It's an indication of whether the advertisements are to be used by a particular application. We want to be able to advertise per application values. We want to have efficient encoding, so there are certainly deployment cases where the same values on a given link can be used by multiple applications. We don't want to have to needlessly advertise the same value twice. We want to be able to support incongruent topologies, meaning that there's a subset of the links in the given topology where a particular application wants to use the advertised values, and another application may want to use the values advertised on a different set of links. We want this to be easily extensible. We have 3 applications, standard applications defined at the moment. Perhaps a few years from now we'll have 5 or 6, who knows. We don't want to have to revise the protocol when that happens. We want to be able to support partial deployment and have this be backwards compatible. We do not want to upgrade one node of the network to support this and have to do something on all the legacy nodes in order to make them continue to work. And we also want to be able to support BGPLS, and we want to be able to advertise the values for all of these applications in BGPLS. So this is covering mostly the changes that have occurred since the last IETF. We got a bunch of comments that said, in addition to standard applications, we'd like to be able to support user-defined applications. So we've redone the format of the TLV, and we now have a standard application bitmask, a user-defined application bitmask, and the lengths of each bitmask before we actually advertise the applications themselves. So this is just a bit more detail on the standard application bitmask. There are currently 3 applications defined. One of them is the legacy RSVP-TE, then we have SRTE, and we have LFA. There's a new sub-TLV for the IS neighbor, the various flavors of IS neighbor TLV. And this is the set of sub-TLVs, the existing sub-TLVs that we advertise link attributes that will also be advertised in this new sub-TLV. That set has not changed since the last revision. We're also supporting this for SRLG. In the case of SRLG, we did introduce a new top-level TLV because the existing TLVs, we had one for IPv4 and one for IPv6. and we did not want to have to allocate 2 TLVs, so we've changed the format a bit so that it supports both IPv4 and IPv6. Okay, deployment cases. These are just some examples of what you would do based upon the nature of your deployment. So if you have just legacy RSVP-TE only, you make no changes. You utilize the same advertisements you've always been using. If you have multiple applications, one of them is RSVP-TE, and you have common attributes and common topologies for both applications, then you use the legacy advertisements. You advertise the new sub-TLV with the set of applications to which those advertisements, link attribute advertisements apply. And you indicate that there's a bit in there that you indicate, I want to use the legacy advertisements. So this basically costs you 3 extra bytes per link. But the actual attribute advertisements themselves have not changed, and they're still going out as legacy.
Les, I have a question on this. So having read both of these things, it seemed like the other presentation was just to not do anything. Is there a reason you actually have to advertise the legacy bit? I mean, why not just have the default be use the legacy values? Yeah,
this is a good question, actually. So with this draft, you have explicit indication of which applications are using which advertisements on a link. In Chris's draft, you do not.
Right. But
That's one of the differences.
Yeah, so yours would work, though, even if you just didn't explicitly advertise the legacy ones.
No. One of the comments, and Chris, I'll make the comment to you, and it works both ways, that I don't think the purpose of this meeting is for you and I to continue to argue. I think the purpose of this meeting is to hear what everybody else...
Everyone else decide.
Okay. So I'm not telling you not to speak, but I'll try to do the same in your presentation. Okay.
There's also an extended period of time you guys could argue after both.
No, that means only Chris and I can't speak, but so yeah, I mean, if you don't have explicit indication, then when you advertise legacy, how do you say, gee, this new application, I don't want you to use those values on this particular link?
Couldn't you advertise a flags with an empty sub-TLV set?
So that's what we're doing.
No, for the new application.
Yes, that's exactly what we're doing. We advertise.
No, so I'm saying you advertise your legacy values, and then you advertise the new TLV with an application mask with the new applications with an empty sub-TLV set, so it doesn't use the legacies, or with new TLVs that it's supposed to use.
So this is, if you look at this slide, you'll see that in the application identifier, we have the length with a flag. So it gives you the length of what are these, let's say, the standard applications or the user-defined application. How many bits are we advertising? And you have a flag that says, I'm not going to actually advertise any link attributes specific to these applications. I want you to use the legacy advertising.
You know, I understand that, but that's not what I was saying. What I was saying was that if the default is to use the legacy, then all you need to be able to do is say what doesn't use the default, right? Because if you don't say what doesn't use the default, so everything uses the default unless you tell it not to.
Yeah, and that's a fundamental difference between the two drafts. Okay?
But it would work in yours too.
No, it does not work. Peter, you want to?
It's Peter from Cisco. So I guess the difference is that we always specify the set of attributes that we want to use. We never fall back, right? Unless we say LBIT, which means everybody use default. But if you advertise something for a specific set of applications or for an application, then you have to specify all the link attributes.
In other words, you do not have, unless you have
positive advertisements, not the negative one.
Unless you have explicit indication of which, for each application, what advertisements are to be used, whether they're legacy advertisements or the new advertisements, then you have no way of saying, gee, I have a bunch of legacy advertisements on this link, and I do not want this application to use them.
Do you union them? I guess okay. I can, maybe we can take this offline, but I don't understand why this is technically not feasible. If I advertise the TLVs that I want with the new application TLV you defined, that's what the application should use.
So the other alternative is I want to use the same set of link attributes on a given link for both RSVPTE and a new application, and you're telling me I have to advertise them twice. Could be done, but it's less efficient. What we've defined here is a way of saying I don't have to advertise the link attribute values themselves twice.
So you're saying that this has to do with whether it's enabling the application at all on the link. That's the thing that you're getting at.
So do not use the word enabling. We're deliberately staying away from that. We are saying a set of applications, we're giving you an indication as to whether these attributes are to be used by this application. It says nothing about whether the application is locally enabled on that link.
Okay, well, what I'm saying is that if you didn't specify anything, then all applications are enabled for those legacy values.
And that's exactly what we don't want to do.
I understand.
Okay.
I don't understand why.
Because then if I don't do that, I cannot support incongruent topologies.
That's about enabling links on the application.
No. One of the keys is to understand, number one, we're not talking about enablement. We're talking about using a set of advertisements. And we're saying for a new application, we are not making the assumption that all of the links for which RSVPTE advertisements are being made are also useful for this new application. The easiest way to think of this is I have a partial deployment of SR. I'm running RSVPTE and SRTE in my network, but I do not have a fully congruent set of links for both applications. So I have to be able to say on these links, SRTE is not using the RSVPTE advertisements.
And that's subtly different from not enabled how?
It's if you have to look at the encoding. Okay,
But less, this is in a certain way a bit of a deviation how we historically used to migrate protocols. I mean, when we did actually, the IP reach to extended IP reach transition, right? There was always this sort of inclination to, make sure that the metrics are congruent, right?
I don't. This goes. I know we could deviate on this for a good while. I don't think that description is accurate. One of the reasons that the extended reachability TLVs were invented was because the old style metrics were too limited. 1 to 63 was just not enough range for us. And how you migrated is one thing, but the eventual goal of migration was now I have a much bigger metric space to play around with. The goal wasn't to stay within 63. So but I don't think these two things are analogous.
During the migration window, you want to ensure that both new style actually also goes with 6-bit metrics as with old style, and after you have converged your network to the new software set, you can assign your fancy metrics.
But
so
here
during the migration window, there was congruency. That's what I'm trying to say.
But here we're talking about different applications. In the migration between old style reachability and new style reachability, you are not changing the base functionality of the protocol.
The difference is that you want to be able to have this congruency. And I would say there is no historical precedence for that.
I would say that the scenario you are describing is not at all analogous. Okay, we're talking about two different applications. We're talking in this, if we use the examples of RCPTE and SRTE, there is no requirement that says you must run both of these on the same set of links. That's completely different than running ISIS and advertising reachability in two different ways.
So I have to ask again, when you say running on the same or different set of links, that is not enabling on those links or not?
So it's easy for me to fall out of my strict use of terminology And I emphasize again, we've made this point in the draft. I'm making the point in the slide. I apologize for miswording.
I don't understand how it isn't, so that's why I keep attacking.
So the easiest way to understand this is to use the example of LFA. I advertise link attributes for use by LFA. Maybe some node 5 hops away, based on what I advertise, decides which LFA he prefers. That says nothing about whether locally I'm using that link for repair. That's based on a completely different configuration. How am I doing?
Yeah. Well, so let's keep going, and because we have Chris presenting, then we also have time to sort of also, if we had both, that digress further.
Okay. So where were we? Okay, so again, this is the deployment case. You have 2 applications. They are using the same set of advertisements. What you do is you use the legacy advertisements because one of the applications is RCPTE, and you include this new sub-TLV that says here SRTE is using the legacy advertisements on this link. You do not have to duplicate the actual link attribute advertisements themselves, which is what takes up all the space. Here's a case where you have multiple applications and at least some of the attributes are not shared with RCPTE, and or there are some links that you want to use for the new application. You don't want to use that link for RCPTE. You use the legacy advertisements for RCPTE. You use the new advertisements. In this case, you set the L bit as clear, meaning I'm not using the legacy advertisements for the new application. And in those cases where your link attributes are the same on a particular link, you do have some duplication. These are a few examples of use cases. That hasn't changed. There is an alternative proposal. Chris is going to speak to that. Way back at IETF 97, we at least all did agree that we want one solution. We're talking about this both in OSPF and ISIS, and whatever we decide, we want both working groups to follow the same solution. We have asked for working group adoption. By my last count, this was the opinions expressed.
They're not all public.
That's completely true. I'm just reporting what has been on the list. Okay. So this is the comparison between the solution described both in the Ginsburg draft and the Seneca draft, and the comparison against there's a pair of ISIS drafts. The equivalent, the second draft, the TE attribute set draft just came out pretty recently. There isn't an equivalent in OSPF yet, but I'm assuming you would do the same thing in OSPF if you were moving ahead. So this is sort of a comparison of, again, the first column is the set of requirements that we had when we started out to define this solution. And we look at what happens, what level of support we have. Obviously, in our draft, we've defined a solution which meets all of the requirements. In the case of the competing draft, we still do not have a way of indicating attribute usage. The competing draft defines application enablement, which is a different thing. There is no way to support incongruent topologies, and this goes back to the discussion that we were just having. We don't have a way in the alternative proposal to say, I don't want to use this set of advertisements from the legacy protocol. The only thing I can do is advertise different values. And then we get into the backwards compatibility and partial deployment. In the case of our draft, there are no backwards compatibility issues. You can do partial deployments. You have to do absolutely nothing on the legacy routers. There's no configuration changes. You do have to be careful on the new routers as to how you advertise things. I've given examples of that. But for the legacy routers, there's absolutely no changes required whatsoever. In the case of the alternatives, there is a solution proposed about using affinity on the legacy routers to filter out those advertisements that look like legacy advertisements, but which you don't actually want the RCPTE to use. The other important point relates to BGPLS controller support. Part of the alternative solution is to get away from standard bit assignments for applications and to have this all defined at runtime via configuration, which makes it very difficult indeed for BGPLS to support this. So with that, I don't know how you want to run this. Whether you want to put questions or comments
I think
to the end.
any questions you have on the specifics of this one, you could do right now, but we do have like 15 minutes or so scheduled to talk about that.
Bruno de Crane, Orange. I haven't read the draft, sorry for that, so I'll focus on use cases.
I'm so disappointed.
You presented 3 use cases. All are RZPT specific, so it's RZPT only, RZPT with other application, same values, on RZPT, other application, different values. So we have another use case, which is no TE. Mm-hmm. Let's say I'm currently using TE advertisement for LFI selection.
Mm-hmm.
How do I use your proposal? Can I keep using the TE attribute just as is?
No, in that case,
No.
you'd simply use the new advertisements. There would be no need to advertise legacy.
Yes, but I don't have any issue currently. So my question is, I am going to be affected or not?
So
I'm not running RZPT,
mm-hmm.
so I don't have any issue with inconsistency between LFA advertisement or RZPT advertisement.
Right.
And with this proposition, would I have any interrupt issue or new things to advertise in the AGP, or can I still advertise the TE, the regular or historic TE advertisement, just like today?
So I think you have to consider where you're starting from. If you have a deployment, for example, where let's say you fully deployed SR, you're using SRTE, but because today we have no way to advertise link attributes other than the legacy, all of your boxes are using legacy advertisements for SRTE.
Yes.
Okay. So in this case, if you have partial deployment, if you upgrade part of your network to support the new, then you have 2 choices. One is you can continue to use the legacy advertisements everywhere, and you can set the legacy bit for the new boxes to say use the legacy advertisements, and you only advertise legacy. Or you can sort of prepare for the your eventual migration to completely upgraded set of routers, and you can duplicate the advertisements with the new advertisements and the legacy. You have both of those choices available to you.
And Cisco is going to make this really easy for him, right? By not making him set anything. I mean, I assume.
Of course.
Yeah. I mean, when you say you set the L bit, it's just because it's on new software version, right?
Yeah, I mean, I don't think we want to start getting into, how we define the CLI and.
No, but I mean, his
implementation,
question
but-
from an operator standpoint is, my network works. Why are you proposing something that's going to change the protocol in a way that might make my network not work?
Yeah, and I'm saying if you're happy, you can simply use all the legacy advertisements that you're using today, and the only thing that'll happen is on the new boxes, they will send out an advertisement that says, please use legacy for SRTE. And from your standpoint, you should have to do nothing.
Okay. Can you add a section in the draft to cover
Sure.
that use case? Thank you.
Sure.
Okay. Is that the order you wanted? I didn't actually ask you which one you wanted to do first.
The order you have listed, the PE protocols draft.
Okay.
This one, right?
Yes. So this is the draft that we first published in fall of last year, and we presented in Seoul. It deals with this one sort of very clear use case that that Les has referred to, and it does so in a very straightforward manner by advertising the protocols that are enabled on a link. So this is the same use case that we described in the draft and we've described before, but I'll review it again because it's been talked about quite a bit. So the actual use case that drove this was this proposal is where you have a centralized SR controller for doing traffic engineering, and it's learning about the network either via the IGP or BGPLS, learning from the IGP. And it needs to know the configured bandwidth on the network, the maximum link bandwidth attribute. So which is quite reasonable. They're all shown there. This advertisement from Y says, okay, the link from Y to Z has 30 gigs of bandwidth. Now, if it's just an SR only network, there's no issues. If there's an RSVP only network, there's no issues. Even if you have an SR and an RSVP network where they're congruent, essentially, SR and RSVP are all enabled on the same links, there's no issue. However, if you have SR on some links and RSVP on other links, then you can run into a problem. Because if you also have RSVP running, how does existing RSVP ingress routers, how do they figure out that a remote link has RSVP enabled on it? And so this is a typical advertisement here for ISIS, and this actually never got standardized for ISIS or OSPF. For ISIS, different implementations have used different criteria for deciding. So we worked together with Les and others to figure out what different implementations actually trigger on. What sub-TLVs they use to figure out, do I decide to include this link in the CSPF computation for computing RSVP signal to LSPs? And so this is the set of implementations with their origins obscured. And it turns out that, we weren't lucky here, that people decided on different things. And so, you can't just say, well, it was never defined, but everyone did the same thing. There is no de facto standard here. So for some implementations, the fact that maximum link bandwidth is advertised is going to make the RSVP ingress router assume that RSVP is enabled on that link. And in this particular case, the service provider is transitioning their network from RSVP, and they're moving it out of some parts of the network and transitioning that to segment routing. So they'll have scenarios where they don't want an RSVP ingress router to try to signal an LSP across a link that doesn't actually have RSVP running on it. It will fail the signaling, and then they'll figure out and try something else, but that extra signaling is not good. So we wanted a very direct indication of what protocols are enabled on that link. In particular, if RSVP is enabled on that link, to sort of clear up this lack of a standard way of deciding that. So there's a short-term workaround, which is pretty straightforward, which is using admin groups. Basically, in this example, suppose that RSVP is not enabled on all those links on the left in red. You have an operator-defined admin group, say in this case admin group 4, that means RSVP is not enabled on this link. You include that in your constraints for CSPF, which is straightforward to do in all implementations that I know of. And that will solve this problem in the short term. In the long term, straightforward TE protocol sub-TLV seems to make the most sense. For this use case, we specifically say we introduce this new TE protocol sub-TLV, which has a bit that says RSVP is not enabled or RSVP is enabled. And then we don't have to worry about these different implementations. So long term, this seems like a reasonable approach to having a link advertise exactly what it is capable of supporting. It can, in this case, it can support RSVP signaling to address this use case. The proposed encodings are pretty straightforward. It's a new sub-TLV inside of TLV22 and the appropriate V6 and MT multi-topology versions. And it basically, at this point, defines two flags, an RSVP flag and a segment routing flag. Now, we've gotten some feedback on this proposal about the precise interpretation of the segment routing protocol flag. The concern that's been expressed is that the segment routing topology is basically congruent with the IGP topology. That's important for running one SPF computation, basically, and not having different topologies. So we shouldn't have a flag that can be interpreted as modifying the segment routing topology, because that creates ambiguity about what topology to run the SPF on. So that seems like a valid concern. We think there's a valid use case for this segment routing flag, since it can be useful for an ingress router or a centralized application to know whether or not it should actually be expected to be able to forward traffic over a link using labels distributed with SR. So it's useful information. So to address this concern, we're proposing to describe this valid use case and also explicitly say that the presence or absence of this SR protocol flag doesn't affect the SR topology. In particular, it doesn't affect the shortest paths computed on the topology. So with the original version of Les's TE app draft, I thought these two were actually in conflict. That is, but the latest versions have made clear that he doesn't want to, his draft does not, the advertisements don't say anything about enablement. This is a clear, so I don't think these two drafts actually conflict. The following draft is in conflict with Les's, and I think is an alternative proposal, but this draft isn't in conflict with Les's, I believe. So as a step forward, we'd like to publish the updated version with the text that addresses these concerns about the SR flag and request the chairs to start a working group adoption poll. So that's it on the TE protocols bit, basically.
Quick observation.
Who are you?
Ravi Torvi, Juniper. So both the drafts, right, are playing with the topology and pruning or adding a link. So you're really trying to use the T attribute to come up with different topologies. Wouldn't this be treated as multi-topology instead of?
So no. So
I mean, this is inline.
So RSVP, you can prune the topology, and I mean that's done all the time. But different implementations. So back in this version here. So in this slide here, it's RSVP is on those links that aren't red. Okay, and RSVP supports that. Segment routing, really the segment routing topology and the IGP topology are congruent.
So congruency and coloring, right? What we are talking about is multi application attributes for a same link, right? And how you use it for your computation is a different matter. But you are fundamentally looks like the conflict is really about how do we make support incongruent topologies. But it is not a problem of T attributes.
So there, I mean, there's two. So this is a very specific use case. Okay. So I have another presentation on that directly addresses the use case that Les's draft addresses. Okay. And so
yeah, all I was trying to say is you don't want to solve with this incongruent topologies. There are maybe there are different tools available.
We had some discussion back in Seoul about multi-topology specifically. But I mean, when you say multi-topology, do you mean multi-topology extensions?
I mean,
those
you're trying to come up with different topology for different application. You're dealing with different topologies. When you talk about
the way that multi-topology extensions are actually implemented, they're very specific to the IGPs. That's probably an even bigger hammer and worse hammer than the one being proposed by Les, in my opinion.
So, Chris, I'm not speaking against you.
Right.
I think this is something we agree on. What all of these drafts are talking about is a particular set of applications. We use traffic engineering in particular. We're not talking at all about modifying the base IGP topology and how the standard IGP SPF is calculated. That's not in scope for any of these drafts. I hope we're in agreement on that.
Yes, we are.
Since I'm taking notes,
AC Lindum. And for SR, if you're using the base algorithm, it is the IGP topology. You know, I mean, there's tweaks you can make, but if you're just doing base segment routing, the base algorithm includes everything that's in the IGP topology.
Correct.
Harish Sitaraman. So the previous slide, the
previous slide?
Yeah. So we just explain the problem in terms of incongruent topologies between two protocols per se. Why isn't this not a good enough solution? I imagine, practically speaking, only either of these will exist in the long term in the network. Maybe that's not a point of consideration here while we standardize, but wouldn't this be good enough?
It depends on the customer, and there's a lot of extra configuration involved. Long term, they would rather not to have to worry about it. It's things that are transitional often end up lasting for a long time, and so kind of leaving this festering might not be such a good idea.
And
there I think there are other use cases for this as well. As I mentioned, in SR and even whoopsie. Are you okay? They were moving the slides on me. So I think it's a general use, fixes a problem that has existed for a long time, has been sort of not visible because RSVP just sort of worked and all the topologies were congruent. I think this is a clean solution that is worth pursuing. So actually a scenario, I suppose you had a link that never had RSVP on it, but you wanted to, you had RSVP in some part of your network, had a link that never had RSVP on it, and you wanted to be able to advertise the bandwidth for that link. That's kind of a problem where this solution is, the workaround is sort of less desirable. So.
Chris,
Okay.
final question from my side. Is it fair to say that your draft always assumes congruent topologies versus Les's draft allows to advertise different bandwidths for different protocols?
So this draft doesn't address what Les's draft addresses. It's the following draft that addresses the ability to advertise different values.
So with this one, do you just try to clarify, those loose RSVP semantics that we had over the past
Correct.
20 years?
This sort of de facto heuristic, which didn't cause any problems, is starting to cause problems.
Okay.
So fix it in a clean way, and at the same time, make it generic enough so that you could also imagine adding LDP to that list.
Mm-hmm.
That would actually, I think, map better to the BTPLS extensions there. I think it has LDP in there, if I'm not mistaken. So this is a general, it focuses on the actual protocol that is enabled on the link, what you can forward, what label distribution protocols you can use to forward traffic over that link. So now moving on to the next slide, or the next deck.
This one, right?
Correct. So this is the draft that addresses the same problem space that Les's draft addresses, but comes from it in a different way. And so first off, I want to say that the working group really needs to do some homework on the actual use cases, because up to this point, we're making arguments based on either undocumented use cases or very few use cases for this capability. So at this point, the most concrete use case for the ability to advertise different values of the same link attribute in such a way that different applications can use those different values on the same link. At this point, the most concrete use case that I can identify from a real customer network is allowing applications to use different sets of SRLGs. So we, my co-authors and I, adopted took a look at Les's draft and see some issues with the way that it is, the encoding sort of require you to eventually deprecate the existing TE-link attribute advertisements. And we think that the use cases so far presented for this and identified for this really don't justify that approach. So we came up with a different approach that doesn't require deprecating the existing advertisements, and it fits in nicely with the existing framework. So first I'll describe the TE attribute set. I also want to point out that what we ended up publishing in this draft, the encoding is different from the encoding that I first proposed on the list. So just keep that in mind if you make any observations about the encoding. Basically, the first encoding we proposed would have required some duplicate advertisements. This one doesn't duplicate any advertisements. So we actually treat TE attributes and SRLGs using the same basic mechanism, but they're slightly different because of the way that SRLGs are kind of an additive attribute. Typically, you want many SRLGs associated with a link, and whereas the TE attributes for a given TE attribute, there is one value. There's not multiple values. So we adopted the approach that the existing, the attributes advertised using the existing sub-TLVs of TLV22, they're all associated with the default attribute set. So that's the TE attribute set with ID 0. You'll see that this is very similar to the kind of encoding used with multi-topology routing. It's not multi-topology routing, but multi-topology routing had the nice feature that even if you never deployed multi-topology, you were effectively using the default multi-topology ID equals 0 in the existing advertisements. So we adopt the same approach that basically existing routers are already advertising attributes in the default attribute set. And then we introduce a new link attribute set sub-TLV, also in TLV22. It's used to associate any non-zero TE attribute set IDs with the link attributes in the new link attribute sub-TLV. So the actual encodings we borrowed heavily from Les's draft because they're good encodings, but we use them in a different manner. So this link attribute sub-TLV is basically the same used in Les's draft, but it is not put in the sub-TLV that he proposes, but then instead a sub-TLV that allows it to be scoped with this TE attribute set ID. So using these two forms of advertisements, one is grandfathering in the existing advertisements to be attribute set 0 or the default attribute set, and then any new advertisements that need to be for where we need a different value, each advertised attribute gets associated with a TE set ID. And this is similar to Les's list. I've actually, in addition, included the TE default metric. We can discuss that one later, depending on how we go forward, but it seems like that's actually a reasonable one to include as well, that if we're going to allow scoping, we might, of these TE attributes, that's one that could be, could have multiple definitions, or multiple values. So this is showing how the TE attribute set gets used. So basically, this is your existing TLV22 advertisement with also sub-TLV3 for admin group and sub-TLV9 for maximum link bandwidth. And so right here, we're actually advertising no additional values. We're not using any of the new advertisements, but we're implicitly advertising all of these attributes with TE attribute set ID equals 0, the default TE attribute set. So in this case, all of these applications, and these could be RSVP, SR, any application, RSVP fast reroute, SR TILFA, or SR centralized control, they're all able to use these existing advertisements. So only in the case where we need a value for an attribute that is where one application needs to use a value for an attribute that's different from these default values, do we employ the new encodings. So we have this link attribute set sub-TLV, which carries the TE attribute set ID of 1, and then we put in this extra value of the maximum link bandwidth, which in this case is 22. So in this case, applications X and Y, suppose we want them to use the default attribute sets. They do that without any modification. Application Z, on the other hand, it will use the default set for anything that doesn't appear in the non-default advertisements. So we feel like this approach really avoids deprecating the existing advertisements. It puts the sort of complexity on the networks that need this advanced functionality. Okay, they have to worry about these new encodings. But take, for example, Bruno's question about his use case. It continues to function exactly as it is, even as he upgrades the software. He never needs to worry about this new encoding because he never needs to deploy the new encoding. He can eventually if he wants to, but his existing applications will still work. So the SRLG sets work similarly, but they have a slightly different semantics because of the nature of SRLGs. You typically take a union of all the SRLGs on a link. You want to have an arbitrary number of SRLGs or a list or a set, basically. And so again, we use the approach that the existing TLB138 advertisements are in the default SRLG set. SRLG set ID equals 0. The SRLG set scoped SRLG TLV, that's only allowed to advertise non-zero values of the SRLG set, similar to MTID. And that's how we associate, how we advertise SRLGs with non-zero values. So similarly, existing applications can be grandfathered into this framework. They start out, once we approve this approach or a similar approach, they start out already advertising SRLG set ID equals 0 advertisements. When we need to, for an application or a network that needs a different value of some SRLGs for the same link, then we use this new advertisement. Now, the semantics for this is that by default, if you're using, for the SRLGs, we have no mechanism to sort of override a default SRLG advertisement. So we basically just say, okay, if you want when you use an SRLG set, if you say, okay, I'm going to use SRLG set 1, you don't include by default SRLG set 0 because you'd end up, there's no way to cancel out the existing SRLGs in the default SRLG set. But that seems like a reasonable sort of compromise given the semantics of SRLGs. So this is the most concrete use case for this kind of scoping that I have seen so far. For scoping of any of these link properties, either T attributes or SRLGs, I find this one the one that's most relevant to actual problems that people face. Now, when you work through this example using this encoding, it sort of works naturally. So in networks that deploy lots of SRLGs, it's quite natural to have some sort of classes, groupings of SRLGs. And one example of groupings is that you have links, IP to router links that correspond, underlying, they have either an intra-city fiber, or they can also have inter-city fiber and also, say, intercontinental fiber underneath. Depending on which of those fails determines what SRLGs they belong to. And so it's natural to take this grouping of SRLGs and assign them to the assign SRLG set IDs to them and advertise them so that you can then do, you can sort of take advantage of this natural grouping of these classes of SRLGs. So in this case, we want application X to take into account all 3 types of SRLGs, while application Y should only take into account intercity and intercontinental SRLGs. So they get advertised using the sets shown below, 1, 2, and 3, and the application takes the union of 1, 2, and 3 for application X, and Y just takes the union of 2 and 3 as the SRLGs that it's going to consider as constraints and use them however it will. When you want to add another application, application Z in this case, which is only supposed to take into account intracity and intercity SRLGs, you don't need to touch the routers that are advertising these SRLGs. It's already advertising the appropriate information. And this is especially the case when you have a centralized TE controller where you don't even, suppose Z is a central controller, you never touch the network at all in order to deploy this new application. So we think this is an improvement on.
By the way, Chris, it's hard up against the line.
Okay.
I don't know how many more slides you have. But...
About 4.
Oh, we're over.
Okay. So Draft Ginsburg proposes to eventually deprecate the existing TE-Link attributes in TLV22. The use cases presented so far, I don't think justify doing that. Better to use an approach that has built-in backwards compatibility. I think the proposed encodings limit the attributes to particular applications, and I think that approach actually restricts application development. It's better for routers to advertise properties and applications decide how to use those properties. And it's also not clear what the definition of each of the standard applications should be. I'm going to jump to that one because I haven't really addressed it. So at this point, we actually have 7 or 8 applications that are using these T attributes in SRLGs. We have distributed RSVP, traffic engineering, centralized RSVP, traffic engineering, RSVP-based fast reroute at the PLR, RSVP-based disjoint paths from the ingress router, LDP-based fast reroute, centralized SR-based traffic engineering, and SR-based fast reroute at a PLR or TLFA. I think these are all different applications which are using these. So in this case, are we going to define a standard application for each of these? And what about if we have 2 centralized SR-based traffic engineering applications? Which one of these is the standard centralized SR-based traffic engineering application? So I'll leave it there and have the discussion. How do you want to handle the...
I think if less, I mean, I don't know, are there going to be people, no one's lining up yet, so maybe there's going to be no discussion or just a small one. But yeah, like if the minute we need less, they can probably just come up and we can address questions from the audience. I have a sort of clarifying question in that, I just reread things today, and it just kept hitting into this. Seems like I understand it's more than just a simple TLV format. Encapsulate. What's the word? Not encapsulation. Encoding. Thank you. It's it seems like an encoding difference. The problems we're trying to solve are the same. The solutions are very similar, and it's just how do you encode that solution? I see like there's a more like you're addressing the defining the applications or not. The stuff I was talking to Les earlier about having the default be more non-disruptive. It's just like these things. I'm looking to get Les as a draft that is working group adoption call, right? And he's correct, even though his numbers weren't, that the rough consensus is generally with less draft. I think Chris has some good points. I'm wondering if we can move forward with adopting the draft, but not abandoning the ideas, because at that point, it ceases to be Les's draft, right? And it becomes ISIS working group's draft. And we're allowed to do whatever we want with it as a working group, right? So it's not, I'm not crushing any ideas here. And so one of my curious things are, Chris, if we were to follow that path, do you think that your ideas could still be adopted into his draft. If Les wasn't the only, if he wasn't able to shut you down by saying we don't want your idea, is there anything technically in his draft that keeps these ideas from being put into it?
Some of the vague requirements are a little bit, I mean, even just encodings, I mean, we need to agree, I think, that enablement, what does enablement mean? I wouldn't want to come back to, oh, well, these are the requirements that the working group adopted, because even those requirements, I think, are pretty rough. So if this is a starting point for working group work on it, I'm okay with that. But if we get down to we've already agreed on X, Y, and Z, then
right. So working group adoption is not working group last call, right? I mean, and that's kind of the point I'm trying to get across, is because we want to move this forward, and I feel like you guys have worked together and you've come to a head on certain points, and maybe the working group can work through those.
So I would like to get Les's take on the previous draft that I presented. So is that part of this as well? Because, I mean, those two, I think I would like to agree on that moving forward as well, because these are, as I see it now, these are not conflicting. They solve two separate problems.
Well, I mean, I think everyone else is going to come on something else, but Les, do you have anything quick to say? Like, yes, I'm fine. No, I'd like to talk about that more.
So there are two significant issues to me in terms of what the two drafts provide solutions for. One issue is there's no way, Chris, as far as I can tell, and I've read your draft, there's no way to say I have legacy advertisements on a given link, and I do not want a new application. I don't care whether it's standard or user-defined or whatever. I don't want a user application to use these. You don't have a way to do that. The second issue, which I think is far more important actually, and it hasn't, I don't think that either presentation has had the time to make this as clear perhaps as we could have, is with Chris's proposal, you do not have any standard bit assignments. So all of your mapping between a given application and the value, whether it's a bit value or whether it's a scalar value, is done by dynamic configuration. And if you do this, then I don't know how you pass this information via BGPLS to a controller, so a controller can understand that these values that were advertised are being used by application A, and these values are being used by application B. Those are the two most significant issues for me.
Right. So my question was actually about the TE protocols draft. That okay.
No, that presentation.
My first presentation, I proposed working group adoption of the TE protocols draft because it does not seem in conflict with your draft. Do you agree with that or not?
Just quickly, you can say you think it's in conflict.
I do not. I think it's superfluous.
Okay.
If you use our draft, you don't need the other draft provides no value.
So I mean, given that response, I have to say that the discussion you had earlier about enablement is going to come back in these discussions continuously.
And I do think that there's overlap. I do think that Les may cover both cases. So
the current text does not say that. I know. And in fact, it seems to say that it doesn't.
Yeah.
Well, one place it says it does, and then it says it doesn't. So,
so I'm taking it from the trying to move forward case of, once it's out of authors' hands and into the working group's hands, we can start making changes and make things clarified. And if one of the things is we do want to cover enablement or we don't want to cover enablement, if we decide not to cover enablement, then and you want a draft that does cover that, then we can bring that in too, right? If we want to exclude it specifically from the other.
Yeah, okay. We'll discuss a proposal later on, I suppose.
Yeah, so, and this is also open to everybody's comments as well, like how to move forward. Tony.
Tony P. Juniper. Hey, Chris. Frankly, looking at the stuff, I'll put them into a room give them pizza, and start to slowly suck out oxygen until they agree on a common set of requirements.
We thought we did that last time, but the oxygen part wasn't.
Well, so you didn't do it well enough. I think adopting one draft without the requirements being met where everybody agrees on you just have a different set of conflicts.
Okay.
So I would force them to come with a list of requirements they agree on, and if they disagree, set of requirements which are orthogonal, and then solve it with 2 drafts. Otherwise, we'll just drag the stuff on. It will become more and more of a festering thing. Suggestion.
Hannes Gredler, RT Brick. One of those, I would say, habits that you get used to for working too long with Yakov was asking first, can it be done using existing protocols, right? And it looks to me, both of you, you're trying to reinvent multi-topology routing, albeit in a TE context, right? So may I ask you one thing? In the TE topology registry, we have probably 99% unutilized as per today's IANA table. So do you think it would be possible to allocate, for Chris's 7 different applications or for SRTE to carve out a code point from that topology area? Because then everything is clear, all the semantics are there, we don't really need sub-TLVs, we have a perfect way to encode already being defined.
So clarification, are you suggesting that, for example, for bandwidth, that we have n different code points for bandwidth?
No, I'm just saying whatever you want to advertise in RSVP, that is today, the legacy topology 0, but grab something else, a new topology ID for SRTV, right?
So I don't see how that proposal differs functionally from either of our proposals. We're putting something in front of the advertisements that says, that scopes those advertisements to 1 or more applications.
Right.
Okay, that seems to me what you're asking for. I think we're both doing that.
Right. And I'm asking, why can it be done using existing protocols? Why do we have to reinvent a new protocol? Why do we have to go down the business of sub-TLVs?
By protocol, you mean TLV, right?
I just going to comment. If you go down the multi-topologies, I mean, granted, we're going to have some differences in coding in OSPF. We're not going to go that way. I mean, we don't have it implemented. So we are not going to just to support multiple applications. So that would mean divergence. I'm speaking as where we are today.
That sounded like a chair speaking to me.
There's very little adoption of multi-topology in OSPF, and it's only for OSPF v2.
So Tony P again. So I emphasize Hannes' point. I saw the same discussion on V6 migration on source destination routing. Every time it went 2 years around, and at the end, basically MT has been used. So take it as a data point. I'm not pushing for it, right? But Hannes has the point over many, many years.
Okay. So I feel like we resolved this conflict, but I do like Tony P's idea that let's make sure we're working, the requirements are very clear. I don't want a requirements document. We can just do it on the list. And we'll make sure that we're trying to solve the same problems. And if we are, I think we, yeah.
I think a requirements document is actually what's needed here.
Then we can put it in the draft.
And use cases, put it in a draft. But so I think, arguing back and forth on the list without text to just go to is just going to waste everyone's time.
But aren't we close?
We don't need. So we have very few actual use cases for this, actually documented.
Well, use cases and
Deployment
requirements.
cases are actually in Les's draft are about transitioning without actually justifying the need for it. So
So
They document. So
I'm sorry,
we actually
that's-
came to this conclusion in Seoul.
this is not accurate. If you read the draft, the draft specifies what it's trying to achieve, and it gives clear examples of why it's needed.
Yeah.
So-
Okay. So use cases and requirements are slightly different. Right? Use cases are examples of the requirements, and I think Tony P's point was we need to define the requirements. That's like asking what problem are we trying to solve.
Yeah,
So
and
back to
again,
Seoul, Stefan Litkowski
Volunteered to edit a document on use cases and requirements, whatever we want. That got shut down by, basically an argument from Les on the list without any real response to that. So I still think that's the right approach. People, I'm sure Les will claim that I'm just trying to slow this down, but this is going to go nowhere without actual use cases.
so we have a real problem today. We have RSVPTE and SRTE, and they are, in some cases, deployed in the same network, and we have no way to separate the advertisements per application. This is not a theory. This is not something that's happening in the future. This problem exists today.
I would like you to document those use cases very specifically. You haven't. You haven't. Yes. Correct. I am.
Okay. So go ahead.
Ron Bonica, Juniper Networks. Maybe a good idea would be to have a very brief interim meeting where we get just the use cases right, get them documented, not so much in an internet draft, but in some email by you guys who are chairing the meeting. And then once we know the use cases and the requirements really specifically, then we might have the solution conversation with a little more
I
grounding.
think an interim meeting is the only way to do this because I don't want this not resolved by Singapore. This dragging on. Okay. Yeah, I think we're kind of out of time.
Jean-Marie, so I'm not helping in progressing. We're just trying to answer last question. Hannes mentioned multi-topology, which does allow to support different advertisement for a given topology. There is no standard code point for that, but I could handle it using multi-topology. So there is standard way to do it already.
So I think there's a big difference between stating an idea and looking at what the current encoding actually supports. And I don't think what Hannes is proposing is fundamentally different from what either of our drafts propose. You can define different bits, you can define a different code point,
Functionally speaking,
you
we
can
agree.
define a different hierarchy.
There is an existing
But
standard, there are individual drafts.
What Hannes is
Strong
asking
difference.
for, as I understand it, is I want a context and then code points. And both of our drafts provide that.
We got to move on.
However, Hannes's proposal and my proposal have built-in backwards compatibility. This proposal proposes to eventually deprecate the existing advertisements.
But Chris, I don't want us to be going tete-a-tete, but that's absolutely inaccurate. It is possible to deprecate the existing code points.
We have to move
It is
on.
not a fundamental part of the
We can't
draft.
keep having this argument.
Okay.
All right. So I've literally eaten out all the slop and everything else, including the time of Ross's presentation that we recovered. We're going to do reverse, and then we're going to do spine leaf, and I'm putting flexi at the end because it's being presented in C camp. So in case we run out of time, it still will be presented somewhere. So reverse is you're up.
I'll try to be quick.
So you have 11 minutes.
Huh?
You have 11 minutes.
Okay. So I'm Michael Abramson. I'm here because Naming and Shane are not here, so I'm presenting this. This draft is originally by, I think it was initiated by the email I sent in 2010. So it's been going on for a while.
You have a thing.
Okay. So this is the working group draft version 6. It updates based on feedback, and there's some use cases added. You can read here, it removes the S-bit, link overload, link attribute, and so on. And yeah, here it was first presented in as a draft in IETF 79 in Beijing, and this is November 2010. So the use cases are node and link isolation, so that you can remove yourself from a LAN and everybody else can still use it as before. And it's also about like when there is work going on a LAN card and you don't want to use any of the ports on that LAN card. You don't want incoming traffic or outgoing traffic. Select the VCMP. It can be used for IGP, LDP sync when before, so that ISIS you can tell them, okay, I don't want any traffic on this link until LDP is fully synchronized. And yeah, generally you can influence the incoming traffic on that link. So there's a new TLV here. Now I'm a bit deep into the details that I don't know well enough. So I'll just leave that up here for everybody who knows this better than I do. It applies to multi-topologies. You can configure this locally to overwrite the signal from neighbors. This works both on LANs and point-to-point. Support of T metric and sub-TLE for CSPF calculation. And on the LAN, the dis node is doing the work here for changing the metric from the pseudonode. And on point-to-point, you just tell the other guy to add to the already existing metric. There is work here about OSPF, and I'm not an OSPF expert. I talked to AC yesterday to understand what it was doing here, but it has similar. There's part of the solution space here that is being done in OSPF as well. And as far as I know, this is quite stable. We have addressed a lot of comments and so on, and we're requesting last call.
I don't know if you covered this in the use cases, but the one that Peter Lofberg recently came up with a different solution, and the reverse metric actually solved it, which was if you're getting a crappy signal on your fiber, right, on your end, you know that it's bad, so you can advertise the metric, that the fact that it shouldn't come towards you.
Yeah. So there's the whole thing about if you are close to your prefec limit where you're going to start getting bit errors, you can say, okay, when this happens, I want the metric to be increased, so that there is no, and so you increase the metric you're announcing and you're telling the other guy to do that as well. And so you can set optical triggering signals if you're, and maybe you can have error counters trigger this and so on. And so yeah, there's that use case.
I mean, the main point is there's no way in the protocol to do that right now, right? To say that I've got a perfect signaling to my neighbor, but I'm getting crap from him, right? So this addresses that too. So I was just going to move to it has been around for a while. Just to get a general feeling of the room. Does anybody object to this going into last call? Do we think we have more work to do on this, or it's a bad idea?
AC Lindum, this is just a question. Mm-hmm. For that last use case, can you talk to the reasons you would use this as opposed to automatically taking the link out of service, not out of service, but out of your.
So basically, this is in my Relo 2010 email. It's like I have bit errors on my link. I don't want to use it right now, and but it's not bad enough that I never want to use it. And if my redundancy goes down, my 0.1% packet loss is a lot better than 100%.
You want to discourage usage.
Yes, but I want to use it. I want to use it in an emergency. I want to use it, but not for normal operation.
Yeah, but you're also saying take it out of service, right? This is addressing only one direction, right? Because the other
you can shut down ISIS on. I mean, take it completely out.
Yeah, but I'm saying the case Peter's interested in, which is the interesting case, is that you have two fibers, right? They're unidirectional, and you've got bidirectional connectivity, but you might only have crap on one direction, right? Yeah. So I don't want to take the link out of service because it works perfectly fine that way.
Okay.
and it's bad this way.
Yes. Okay.
So I
right.
want to keep using this way.
Yes. Right. No.
Okay, so but the question again was, does anybody object to going to last call with this? And that no one raises their hand. Do people think it's a good idea? It's always a bad question to ask. Okay, we got the few. There we go. All right. Not as energetic as the last time we asked.
Do you want to ask? Everyone thinks it's a bad idea as well.
Yeah. No.
No. Okay.
What? Yeah, so I was asking if people thought it was okay to take this to last call. Yeah, okay. I asked it different ways now. So I think it's okay to take it to last call. We'll I guess, do we have to ask on the list again? Or? That's all. Right. I just start the last call, right? Yeah. Okay. Okay. So we'll do that after. All right. Next up. Thank you. So the next up is spine lead. Huh? No, not this one yet. I'm sorry, but Les, you come next because you're going to present in C-Camp, and if we run out of time, it still gets presented, right? Yeah, I know. Hannes hasn't caught up with what I was my juggling here.
Communicating.
Yeah, I'm not communicating. So we're doing the spine lead now.
Okay. This is what I'm going to cover. So the draft was first published in November of 2015. We introduced a new version in March, which introduced the leaf set advertisement to allow leaf nodes to direct traffic away from the spine nodes, from a particular spine node when you don't have full connectivity. You'll see a clearer example of that later in the presentation. We published a new version in June, borrowing some ideas from Russ's fabric path. We included a tier level so that nodes could automatically detect what tier they're at least in most cases. And we also made the reduced flooding an option, that if you want to deploy it without that, you have a way of indicating that. So this is what the new TLV in Hellos looks like, and we introduced the tier portion of this to indicate, so that a node can indicate what tier it's operating in the topology. And there's a T-bit to indicate whether that value is valid or not. So while you're still discovering what tier you're at, people can know that you currently don't know what tier you're at. The lines in blue are sent by the leaf nodes. So a leaf node will indicate with the bit that I am a leaf node. And it also can optionally indicate for an east-west path that it can serve as a backup default gateway. Again, that's optional. And the green is sent by the spine nodes. So a spine node can indicate that I can be used as a default gateway. We introduced the use of a circuit scoped LSP, a la RFC 7356. This is sent in both directions, potentially. The spine nodes send it. I can look this way. When the spine nodes send it, they advertise the list of the system IDs of all the leaf nodes to which they currently have connectivity. And the leaf nodes can use the CSL LSP to send a request. This is used by default. The leaf nodes will use any spine node that it wants as a default gateway. But if you have a spine node that loses partial connectivity to some of the leaf nodes, then we want a way for the leaf node to be able to get reachability. First of all, to know which spine nodes have full connectivity and which ones do not, and also potentially to get specific reachability information so that it knows which spine node it may need to use for a particular destination when the default is not viable. Okay, the extension basics. So we start out with 2 layers. At the aggregation layer, we're just doing normal ISIS, normal flooding, normal exchange of PDUs. The leaf node will send a hello to the spine, and it will indicate that it's at tier 0, and it'll set the bit that says on the leaf node. It will flood its own LSPs to the spine. And optionally, you can use a circuit scoped LSP to send an info request to the spine node. The spines will include an indication in their hellos that, gee, you can use me as a default, but they will not flood LSPs to the leaf nodes by default. There's a way to turn that off. And they can use the circuit scoped LSP to indicate, here's the set of leaf nodes to which I currently have connectivity. The leaf nodes will then only use a default route to the spines to forward traffic. And you have routing above the aggregation layer as normal. And okay. Sorry, I didn't do the animation, so I don't know where it stops. So here's an example of what happens when in a link and or node goes down and you have no east-west links. So again, we're flooding normal ISIS between at the upper tiers, and the leaf nodes are indicating that they are at tier 0. They send their own LSPs to the spine, but nothing else. So we have a link failure with, I guess we have S4. Where's the? What happened to this? Yes, I know, but I didn't do these. So oh, okay. So we have a default route either via S3 or S4. And okay, so S4 has lost connectivity to L5 and L6. And because we have an exchange from the spine nodes that says these are the leaf nodes that I can currently reach, the leaf nodes detect that there's an inconsistency, that not all the spine nodes have the same set of connectivity. And so they can end up rerouting traffic to, since S4 no longer can reach L6, L4 can direct traffic via S3 for the destinations that are reachable via L6. I guess here's where the link goes down. Thank you. Sorry. Yeah. Yeah, okay. Anyways, the general idea here, and I apologize for the confusion here, is that we've introduced a way to, since we've reduced the flooding, the leaf nodes no longer have the full link state database. So by default, they just go to any spine node for any destination they want to reach. But in those cases where you don't have full connectivity, rather than flood the entire LSP database to the leaves to cover that case, we provide selective advertisements so that the leaf nodes can know okay, this spine node can't reach the set of destinations, I can go via another spine node. But we only have to send the information that is not available on all of the spine nodes. So let me whiz through. So what are we trying to achieve here? We're trying to achieve extensions that are specific to data center requirements. Flooding is the big issue there because one topology change can literally turn into hundreds, if not thousands, of duplicate LSP updates. We're doing this with the well-known IGP, so we're not requiring an additional protocol. And we have available to us all of the existing features that are available in the protocol. And it's possible to also do traffic engineering if that's required. We've now introduced in the latest version of the draft auto tier discovery. This is again from the Open Fabric draft. We incorporated this. This helps with auto configuration so that you do not have to actually go into each node and configure what tier they're at. Russ has some additional extensions. The only thing we've put in here is you have to configure the leaf nodes and say you're a leaf node, but all the nodes at above the leaf nodes can figure out what tier they're at, basically by using Russ's original idea of figuring out how many hops away they are from the leaf nodes.
Do you have a final slide?
And I think that's it.
All right. So we cherry picked Russ's good ideas and put them in this one?
Yeah, you could say that.
Okay.
But with his permission.
Okay, thanks. Yeah, so we have 9 minutes left for the Flexi.
Hello everyone. This draft is about ISIS. It's about ISIS extension for Flex Ethernet. Okay. So first of all, let's have a quick overview.
Yeah.
Okay. Okay. Yeah. Yeah. Okay. Sure. Thank you.
Pull it down a little bit more.
Yeah.
You
Okay.
Hold it. Yeah.
Great. Yeah. Yeah. Flex Ethernet, in short, Flex-A, is a technology that can support a variety of Ethernet mic rate that may or may not correspond to existing file rate. This is achieved by decoupling the Ethernet file rate and mic rate. So Flex-A has three major features. The first one is bonding. It's just like a lag. Multiple interfaces can be bonded into a single pipe to form a larger and faster interface, hence to provide more bandwidth. And this is how Flex-A supports mic rate greater than physics rate. And subrating and channelization are two technologies that can be used to support mic rate less than physics rate. But they are designed to address different use cases. Flex-A also introduced a concept of slot. Based on a calendar, it can be the Ethernet flow can be dispatched to correspond slot. And each slot currently each slot has a granularity of 5G, but it may support more granularities in the future. For example, 25 gigabit granularity is considered in OIF implementation agreement version 2. So here are some terms about this Flex-A. The first one is Flex-A interface. Flex-A interface is a technology that can support mic rate less than physics rate. And this is how Flex-A supports mic rate greater than physics rate. It's a bounded interface that is consists of 1 to 254 1 gigabit interfaces. And flex interface can be channelized into multiple sub-interfaces. And a link that connects two flex interface is called flex link. Okay. So a link that connects two flexi sub-interface is called flexi sublink.
Mark, would it be a good analogy to say that what you've done is you've taken lags plus a number of other proprietary layer 2 features, and you're attempting to standardize them with Flexi for Ethernet? Like this channelization, a lot of people do this in proprietary ways right now, right?
Yeah, maybe. Yeah.
Also, there is the non-proprietary ways. It's called GPON, EPON.
Okay.
You've got about 5 minutes left. I don't know how long
Okay.
the presentation.
It's very short.
Okay.
Yeah. It's a use case of Flexi. It can use Flexi to do interface or link-based network slicing. For example, Flexi link can be sliced into multiple sub links as one, and a set of Flexi links can be allocated to a user or service to form a slice network that have dedicated resources. And the RSPs of a user or service can be established over those links, and for example, through the RCPT signaling or by always signal routing. With this method, we can provide interface or link-based level isolation. It's better than traditional, for example, TE-based isolation. So actually, for the advertisement, actually there are two types of links. The first one, Flexi link, and the other one is Flexi sublinks. For Flexi link, it's same like it's just like to advertise a normal TE link, but we need to introduce more link attributes. For example, the first one is granularity, and the second one is how many available slots that our link can support. This information can be used by path computation entity to computer paths and allocate relevant bandwidth to a TRSP. And for the Flexi sublink, there are two options for advertisement. First one, a sublink can be advertised as an individual link, so there's no requirement to do protocol extension. But with this method, it required to configure IP address and to running IGP protocol over the link. This is sometimes considered not scalable because there may be a lot of sublinks per Flexi link. So another way to do Flexi sublink advertisement is to advertise sublinks as a members link of a Flexi link. So with this way, we don't need to configure the IP address and the running protocol over the link. So here's an example how this kind of information can be advertised based on an existing TRV. TRVs. The left side is a sub-TRV that is used to describe switching capability of an interface. So for the Flexi, we just define new sub-TRV to describe Flexi interface to include the information as I said before in the previous slides, 글ranularities and the available time slots, and this information can be used to compute PRP paths. And yes, and next step. So we need actually the extension is under consideration. There may be many other options. For example, this one maybe someone may be think it is not. Maybe it's too. How do I say? It's not a field that is not useful. Maybe can defend a compact encoding to carry its kind of information. And also, we will do some enhancement and optimization to how to advertise the Flexi sublink, for example, to support signal routing and network slicing. And yeah, the draft will actually there are some requirements from the AD and CCAM chairs. They asked me to present the draft here, and also they think the draft maybe belong to that working group. Okay, question.
Julien Maric. So my first comment, you already mentioned it, is to discuss GMPLS extensions within GMPLS related groups, explicitly TIS or CCAMP. My other feedback, which could have been waited a further presentation, but since you're there, I'm raising this right now. The ISCD in GMPLS is meant mainly to identify the technology, the layer you're switching, so as to identify the type of label you're going to use to create LSPs, which is not the use case you're trying to address here.
Yeah.
So clearly there is a strong mismatch between the solution you propose from the protocol perspective with respect to the problem you're trying to address. So clearly you need to split them. There may be some work related to your use case, some flexi within GMPLS, which I think is already tackled somewhere else also, but I don't see them clearly matching there.
Yeah, true. I think, yes, it's a more generic solution maybe is needed to advertise this kind of information, not just for, to design for switching or something like that. Great.
Okay, I think we're out of time. So thanks everybody, and keep your ears peeled for that exciting interim meeting we're going to have. And otherwise, we'll see you in Singapore and on the mailing list.
Thank you.
The combined mailing.
The combined mailing list, that's right.
Okay. The unified grand.
Grand unified IGG.
IGG mailing list.
Use of the multi-quality advertising.